So good evening my dear students, I welcome you to NEET-level. So today we will be discussing electrolysis, it's a part of electrochemistry. So in the last session we have discussed about electrochemical cells, okay. Now we will be discussing about electrolytic cells. So what we have seen in electrochemical cells, so electrical energy will be produced so electrical energy is produced from a spontaneous chemical reaction. It means chemical energy is converted into electrical energy, so it will be possible by a spontaneous chemical reaction here, okay. That is what we have seen in electrochemical cells. Now in electrolytic cells, so chemical reactions are taking place with the help of electrical energy. It means there are some non-spontaneous chemical reactions, but that has to be happen, okay. For example, for refining of metals, okay, for extraction of metals we need to refine those things. So for that we will be using this electrolytic cells or this process. So for example, for extraction of any like metal if we required, for example copper metal we have, that is impure form, okay. Now I will show you how we can do this. So that impure form we need to purify it, right. So generally metal they will be existing in their oxides forms or in their combined state, right, but what we required a pure metal. So for this we need to extract iron from that impure state to pure state. So this is a non-spontaneous process, whereas conversion of metal to its metal oxide, it's a spontaneous process. When it is exposed to normal moisture, what happens? This oxide formation takes place. For example, rusting of iron, that is a natural process, but reverse of it, so in order to bring this non-spontaneous chemical reaction, we will be using this electrolysis process, okay. So what we will be doing in electrolysis process, by passage of electricity, a chemical reaction will be brought up, a chemical change will be seen in here, okay. So this is what we are going to learn in this session, okay. So first thing, before going to study this, I just wanted to tell you, for all the live students, those who are in YouTube, okay, we are going to launch our NEET long-term program as well as JEE long-term program for 2026. So batches are starting from 1st July, okay. So if you are interested, please kindly contact to the mobile number which is scrolling on your screen, okay. Then let us start our session. Yeah, so electrolysis. So what is the cell we are using here? Electrochemical cell, electrolytic cell. So electrochemical cell is the one which we have seen last class. So here electrolytic cells. So in this cell what happens? Electrical energy converts into chemical energy, or using a electrical like energy will bringing a chemical reaction, okay. So now in this process, so in this electrolytic cells, so let us say this is a cell, electrolytic cell. So we have here, this is electrolyte, okay. So now in this I am taking two electrodes here. So let me take these two electrodes here. So now these two electrodes, okay, are connected to external source, something like external battery, let us say, okay. Why? We need to supply electricity to this electrolyte so that we can bring some chemical change in this electrolytic solution, okay. So I am connecting these to the battery, okay, like this, okay. So positive terminal, negative terminal I am keeping here, okay. Now positive is connected to positive here electrode, and this is for negative electrode, okay. This is what we will see, okay. This is a rough diagram you can take for electrolytic cell. So now in this what happens, I am saying there is an electrolyte. What is this yellow color representing here? Electrolyte. So this electrolyte contains what? A cation, anion, okay. So now electrolyte contains cation and anions now. So now these all cations, so here these electrodes we are saying now, so electrodes are of two types, one is cathode, another one is anode. So we have two types, means that is active electrode, inert electrode and active electrode. I will tell you about that. But here I am saying one is cathode, another one is anode. So here what is this anode and what is this cathode? So anode means it attracts anions. It means what should be the charge of anode here? See, attracting anions means these are anions are negative charge, right? Chloride ion, bromide ion, all these are anions. So our anode should be, therefore these oppositely charged ions are attract each other. So I can say anode is what?
Positive.
Remember this. Whereas in electrochemical cell, anode is negative. That negative charge is because of what? Because of electron density present there. Because their oxidation takes place at anode, it means zinc converts into Zn plus 2 giving 2 electrons. So due to that electron density, we are giving negative charge to the anode in that case, in electrochemical cell. Okay. So here anode means positive, you can remember. And in both cells, electrolytic cells and electrochemical cells, oxidation takes place at anode only. Okay. So anode attracts anion. Okay. So here what I am saying, at anode oxidation takes place. Okay. Next, if it is oxidation taking place, then we have one more electrode now. So that is cathode, now can take it as negative terminal. So like cathode we are saying now attracts cations. Cathode attracts cations. Attracts cations. So this process, cations means positive charge. See, and what happens here I am saying? Reduction takes place. So now, does this a spontaneous process or non-spontaneous? We told already, we have told that this process electrolytic, like electrolysis is a non-spontaneous process I am saying. So this happens, like attraction of anions, these things happens whenever we switch on this battery so that electricity passes. Therefore we will get having one positive terminal, negative terminal. So this positive terminal is anode, so which attracts anions from this electrolytic solution, and this negative charge attracts all the cations towards it. Is that clear? Next. Next. Yeah, up to here it is clear now. So now anode oxidation, cathode reduction, you can remember, we will discuss on this again. So now what we need to know is products of electrolysis. Just give a minute. So let me take one simple example, then we will go back. Okay. So products of electrolysis we need to discuss. It means I told you that, for example, I have an electrolytic cell in which NaCl is taken here. What is this?
NaCl.
So this is NaCl solution we are taking. So here we have anode, cathode. Okay. So now this is what I am saying, anode. So tell me at anode what happens? It is anode attracts anion, means it is positive charge, attracts anions. So from NaCl I am saying it is molten NaCl. It means molten NaCl means what are the things present in it? Molten NaCl. I am not saying aqueous. What I am saying? Molten means it contains only Na plus ions, Cl minus ions, right? So now anode attracts which ions from it? Like anode attracts anions. What is the anion there? So Cl minus is attracted towards anode. So now at anode what happens? Oxidation takes place. So this chloride ion gives this electron, loses this electrons and become chlorine gas. Okay. And see, one chloride ion if I take, I should write it as 1/2 chlorine molecule and one electron is released. Either write like this, or you take 2 chloride ions, right, Cl2 and 2 electrons. I write like this. Okay, what process this is? Oxidation. Okay. Now what about another electrode we have? Cathode. So write cathode here. So always remember, by default first write reaction of anode, then followed by cathode, because for cathode what happens, reduction takes place. Now reduction means loss, gain of electrons or loss of electrons? Gain of electrons. In order to gain that electron, that should come from where? Anode side, because anode is releasing the electrons now. So this fellow will release the electron and that will be gaining that electron. So first write anode half, then write cathode. So write, what is this? So what is the cation here we have? So take Na plus. Okay. So for reduction of this, so at cathode what happens? Reduction. Okay. So for reduction of this we required one electron, so that it will become Na. Okay. So solid is deposited here. So here chlorine gas is liberated here. So they will ask you, what are the products formed at anode and cathode in electrolysis of molten NaCl? So what are the products? Chlorine gas at anode, sodium metal deposited at cathode. Like that you need to give answer for every reaction. Then next, up to here it is clear now. So now this, what I am saying, it is molten sodium chloride. So it means there is no other ions except sodium chloride. Okay. Sometimes multiple ions, multiple cations are there, multiple anions are there. So that time we need to have some idea which cation will deposit first, which anion will deposit first. That is what we need to know. Okay. So just tell me before going to that. So I just want answer for this. See, what are the products formed at anode and cathode? Tell me directly.
Bromine gas.
So anode attracts anion. So what is the anion in this? Lead bromide. It means Pb, Br2. Br2. So anion is what? Br minus. Okay. So this will be converting into Br2, half Br2 plus 1 electron is liberated here. Otherwise you take 2 here, 2 electrons and 1 mole of molecule is formed. Okay. At cathode what happens then?
Deposition of
Lead plus 2 converts into lead atom, like this. So this is in the molten state. There is no issue in the case of molten case. Okay. So what is the electrode here we are using? Inert electrode, like platinum graphite electrodes. It means inert means they won't participate in chemical reactions, but there are some active electrodes. They will also involve in the chemical reactions. For example, active electrode means along with this, if the active electrode also present, that may also participate. Now looking at the tendency, which metal, like which electrode, like whether that species, that electrode species is having more tendency to gain the electron, to lose the electron, or this bromide is having to tendency to lose the electron. We need to compare that and we need to decide which will easily give the electrons. So that will undergoes oxidation here, right? Okay. So now in order to know this more clearly, we need to look at this. See here what the statement I have written here. According to preferential discharge theory, that ion will discharge first which requires less energy. So one which requires less energy, that will discharge first. So less energy requirement means what here? For example, see, you have seen that preferential discharge theory, I mean a table of elements I have given now. I told you to remember that. Okay. So now as per the table you tell me, so which is having more reduction potential? Reduction potential, more value. That is fluorine is more value and oxidation potential is more for lithium. So oxidation potential is more for lithium means, for example, we have a at anode, I have anode. At anode I have lithium as well as some other elements like magnesium and also aluminum. So tell me which will undergo reduction oxidation easily? At anode oxidation happens now. So which metal will undergo oxidation easily? Just tell me which metal will undergo oxidation easily? out of this, oxidation potential is more for which one? See, reduction potential is more negative for lithium. More negative means oxidation potential is more positive. So oxidation potential is more for lithium. Then next magnesium. Then next it means oxidation potential is lithium more means that will oxidize easily, more readily. After that magnesium. After that aluminum. So I just given this as an example. Now the one which is having more tendency to lose the electron, that will have more oxidation potential. The one which have less tendency or more tendency to gain the electron, that will have more reduction potential. Okay, gain of electron means reduction now, so that will have more reduction potential. So based on these things, so now you can look here, the cation having higher SRP value. See, the cation having higher SRP value. SRP means stranded reduction potential value. Cation having stranded reduction potential value will discharge first at cathode. So one which is having more SRP value, standard reduction potential, it means it is easily undergoing more positive. More reduction means what? More positive it should have. More positive reduction potential value it should have. That will discharge first at cathode. So at cathode what happens? Reduction. So reduction takes place at cathode. So one which is having more reduction potential, that will reduce at cathode readily. Is that clear? Based on this, we have these orders. Now one more thing, see, anion having low reduction, low SRP. So low SRP, or we can say or high SOP. Low SRP means what? More negative SRP, reduction potential, because by default in the books you will be looking as a reduction potential soon. That's why lithium is having more negative reduction potential we are seeing, right? So we can say it has more low standard reduction potential or more negative standard reduction potential, or you can say high standard oxidation potential. So value will discharge first at anode. Is that clear? So based on this, so look at this. So order of discharging at cathode. So which is discharge at cathode first? See, as we move this side, so gold will discharge, Au plus 3 will discharge first. Okay, and order of discharging at anode. See, like anions generally here, iodide is discharged first and least is sulfate. So these are also important to remember. Okay, so just look at that how they are. And here least should be what? Lithium we can add, because lithium is not included now, so we can include that. Okay. So just remember this. Now let us move further. See, here we have hydrogen is here, H plus is here, hydrogen H plus is here, and sodium is here. Okay, so when we have a solution, for example, let us discuss here itself, electrolysis of aqueous NaCl, let us say aqueous NaCl solution I am writing. Okay, now tell me, so what are the ions at anode and what are the ions at cathode we have? At anode, what are the ions? At cathode, what are the ions we have? Tell me fast. So here I should write, out of this what is the anion we have? So we have one Cl minus, aqueous solution I am saying now. So along with Cl minus, we also have OH minus ion from water. So water contains H plus and OH minus now. So that's why OH minus ion from water. So instead of writing OH minus ion, we can also consider directly as H2. So at anode we have Cl minus ion as well as H2. Okay. So out of these two, which ion will discharge first? This is the one thing we need to know. Okay. And here at cathode, what are the cations we have? Na plus ion, and from H2O, what is ion? Because aqueous means what are the ions? H2O, H plus OH minus. So we can write H plus from water, so that I am writing water only. Okay, these are the two things. Okay, so out of these two things, which will discharge first, they will ask you. So tell me, sodium or H2O? H2O will discharge first as per this order. So it means we should write here, so as from this H2O is coming, I mean H plus converts, reduction takes place now, so by gain of 2 electrons it will form like H2 plus 2 OH minus ions. Okay, so for this reduction potential value is around 0.83 volts. Okay, so even if you don't remember that value is also fine, even if you remember this order is good, it is enough. Okay, and the next, if this undergoes reduction it will form sodium, right? But out of these two, which is possible, which will discharge first? So write this as right mark and put it as wrong, I mean later it will, which will discharge first, that you take it as a correct mark. Okay, like this. So here out of these two, which will discharge first? As per this order, chlorine should undergo oxidation and should release Cl2 plus electron. Okay, and if water is undergoing oxidation, so take 2 moles, so it will be forming 4 H plus ions, and after this it is what, loss of electrons now, so from this it releases 4 electrons plus O2 gas. Okay, so remember what are the products formed here. See how many oxygen atoms are there? 2 oxygen atoms now, each oxygen is oxide here. What is that? Oxide. So minus 2 charge, so converting into O2 form. So what is the oxidation state here? 0. So minus 2 to 0, it means one oxygen atom losing how many electrons? 2 electrons. Like that 2 oxygen atoms are there now, that's why 4 electrons here we got. Is that clear? So you should understand that concept also here, just for basic avoid confusions, that's why. Okay, so now out of these two, which will discharge first? That is the question I am asking. So as per this order, chloride ion should discharge first. Okay, so here I am writing, so Cl, okay, you just take it as like this and keep it as like this. Okay, and so what is the net reaction you have seen? What is the net reaction you have seen?
Chlorine is released anode.
So you can write this one. Which one, what is the product formed here?
Chlorine
H
gas.
plus ions, here also OH minus. So the overall molecule, overall reaction is having neutralized, because H plus and OH minus ions are neutralized. Now I am taking concentrated, let me take this concentrated one. Concentrated NaCl. So here you tell me what happens? NaCl solution. So concentrated means it is also have some amount of water here. So tell me what happens here? So let me take this. See here we have very dilute. So very dilute case, let us understand. So what is a very dilute case means? So here out of this we have H plus, and from water we have H plus, from sodium chloride we have Na plus. So these are the 2 ions at cathode. These are the Na plus and H plus are the 2 ions. So out of that, which will be having more easily undergo deposit? So H plus. So you can write H2 gas is released at cathode. What about this at anode? So what are the ions we have? Cl minus, OH minus. So since it is very dilute case now, so since very dilute case means like concentration of, see here not only reduction potential value, what we need to consider? We need to also consider concentration also. So dilute means here in this dilute case, the concentration of Cl minus ions are less when we compare with the so that's why which ion will discharge here first? So that's why here it is releasing, like oxygen gas is released. Okay, so these also you need to remember. So no change in pH, equal number of H plus and OH minus are consumed here. Okay, so one more thing I wanted to explain. See, in the both cases you have seen previously, at cathode what happened? Deposition of sodium metal, deposition of H2 gas taking place at cathode. Which gas is liberated? out of this NaCl, so we have Na plus ion and H plus ion from water. So we have seen that H2 gas is liberated from water at cathode. What is this at cathode? So but what I am going to say here is, when we use electrolysis of NaCl solution using Hg as cathode and graphite as anode. So what is our cathode here? Hg. So I cannot say here it is exactly active, but I can say sodium have tendency towards Hg, mercury. It is as like sodium metal will soluble in mercury. Okay, so therefore the reduction potential of sodium increases here. What I am saying, it has more tendency na. So tendency to gain the electron by sodium increases when it is having mercury as cathode. So out of this at cathode, out of these two ions H plus and Na plus, which will discharge first? Sodium. In which case? So the reduction of sodium ion takes place here to form sodium, like this. Okay, so this is the possible reaction, not this what will get H2 plus 2 OH minus. So this is not the one which is preferred here. First reaction is preferred. Hope it is clear. And what about the second case? So that's why here they mentioned at cathode C forming. So why it is? Because it forms amalgam with the like you can write NaHg like this. Okay. The next, what about anode case? Anode chlorine gas is released. Okay. And the next this thing is so products of NaCl solution using inert electrode. So look at here. Here we have, see, 1 minute. Where is that sheet I have shown you now? Look at this. Sometimes, see here, in some books OH will be given here, some books OH will be giving here also. I mean Cl, before Cl OH minus will also be given in some books. So actually, you know, here the whenever we have Cl minus ion and water, so most of the cases chlorine will discharge. And see here, if you see like this, so what is the reason in the case of aqueous solution? So the reason here is, see, generally if OH minus is first and Cl is next, what should discharge first? OH minus ion from water. Okay, but when I am saying aqueous solution, see here in the case of aqueous, this H2O is there now. So we know H2O is a weak electrolyte. What is the dissociation we discussed? It is around 10 power minus 14, like Kw value. It means concentration of H plus and OH minus ion equals 10 power minus 7 we discussed, okay, at 25 degrees Celsius. Okay. So based on this, I can say the dissociation of water is not favored kinetically. It means the dissociation of H plus, like see here what is the ion should be deposited, like see H plus ion should dissociate from here like this if it is wanted to go. So it means the dissociation of H plus, I mean from water H plus and OH minus should form now like this. So this dissociation of H plus ion is not favored, it is very slow. So I can use a term called dissociation of water is not favored by kinetically. Thermodynamically it is favored but not kinetically. Okay. So due to this reason, so water is not getting oxidized here, only chlorine gas is getting oxidized. Okay. So this is the explanation you should give. So why water is not like getting oxidized means you should say it has over potential. We require extra energy to oxidize this. Why extra energy is required? In order to get dissociate H plus from water, it is slow process I am saying. If it is slow, in order to increase that we use more energy. That more energy we are using now, that we should call it as over potential, extra potential. Okay. Hope it is clear, but they are not asking in NEET, but they may focus in JEE about this extra potential concept. The next thing is, this we discussed. So let us discuss about copper sulfate. See, copper sulfate, aqueous copper sulfate solution we have. So at anode, what are the like ions we have?
Sulfate ion.
So copper plus 2 and sulfate from here. From copper sulfate, from aqueous we have H plus OH minus. Like this you can understand. So at anode what I should write? So what is the electrode used here? Inert electrode. Okay. So inert electrode won't participate in the reaction, they just act as electrode itself, right? So what are the ions here we have? Anode means anions. Sulfate ion, OH ion from water. So at anode what happens? Oxidation. So out of these two, which will oxidize is first? OH. We have seen this is the least. So this will oxidize to form 4H plus O2 plus 4 electrons. Okay, and so I am not writing this. It forms S2O8 2 minus plus 2 electrons are released here. So which will takes place here? This one we already seen. This won't participate here. Okay, what about the other at cathode? So tell me at cathode what happens? So what are the cations? Cu plus 2 we have? H plus from water. Okay, so out of these two, which will deposit first? H plus or Cu? Just see, I have shown you that table. Where is that? See here, see copper is more than H plus. So which will deposit first? Copper. So it means at anode what happens? At cathode what happens? Deposition of copper takes place. So here you should write Cu by gaining 2 electrons. I am not writing this. Okay, let me write. So this happens but not this one. Okay, hope this is clear. Now see, anode, this is what happening. At cathode, this is what happening. So if you combine these two reactions, so what is the resultant condition of the solution? Because it is acidic, because see it is forming H plus ion after resulting solution. Now see, this is not undergoing any process because it will be preferred first. Preferentially this will undergo oxidation. So it is releasing H plus. So the resultant solution should be, resultant solution is what? Acidic, you should say. Okay. So why acidic? Or you can say pH value is less than 7 because these H plus ions are formed here. Okay. So what are the products at anode? Anode, oxygen gas is released and H plus ions are formed. You should say like this. And at cathode, copper is getting deposited. Copper is getting deposited. So this is a story of copper sulfate, aqueous copper sulfate solution using inert electrode. Let us use active electrode here. It means copper electrode itself is an active electrode here. So it means at anode compartment and cathode, we have cathode as an electrode. Okay. So now tell me at anode, what are the things we have? At anode, what are the anions here? Aqueous copper sulfate. Sulfate ion we have. OH minus ion from water. Okay, the next copper electrode also we have. Okay, these are the things we have at anode. So what are the things at cathode? Tell me fast. Copper plus 2, H plus from water, and copper electrode also we have. Okay, so reduction should happen now. Yeah. So now out of these three, which will undergoes oxidation readily? Tell me. Copper will undergo oxidation. It will form copper plus 2 plus 2 electrons are released. At what? Anode. So at cathode, which element will deposit first? Which ion will undergo reduction first? Here also copper plus 2 should undergo reduction by taking 2 electrons and form this copper. So what you have seen here, see, I am using an impure copper at anode and pure small copper rod at cathode. This is pure one, copper rod, okay, as electrodes. Now what happens here, impure copper electrode is participating in electrolysis process. Therefore, this copper electrode will be getting oxidized and converts into copper plus 2 ions. It means the weight of this copper electrode at anode increases or decreases? Decreases, because copper is converted into copper ions. It is dissolving in this electrolytic solution. These ions are moving towards where? Cathode side, and they are getting what? Reduced and forming copper metal. So this is completely going on depositing on the like cathode electrode. So weight of cathode will increase, weight of anode will decrease. So now can we say this is refining of metal? See, I am using impure one here, pure one here. So all the pure copper is coming and collected over this cathode. Impure one will be like stays at anode, and that will small like comes and falls at this bottom, and we should say whatever the impurity falls at this as a anode mud. What is that? Anode mud. So what is this process? Copper refining, you can say. Hope this is clear. So this is a usage of electrolysis. Now let us see a few questions. Before going to that, see, electrolyte we have concentrated aqueous NaCl we have, okay, inert electrode we have here, okay. So product formed at anode. So concentrated, when I say, when it is concentrated, you should say chlorine. They just say dilute or aqueous NaCl means aqueous, like dilute means we should say OH minus will oxidize to form O2 gas, okay, that is in the case of dilute, okay. See here we have dilute, see, dilute NaCl we have. So O2 gas is formed at concentrated Cl2. So in both cases H2 only at cathode, we seen that. When case of fused or molten, chlorine and sodium will deposit, okay. Sodium chloride with at cathode mercury as electrode, sodium will deposit, sodium amalgam will be formed. At anode, chlorine gas will be released, okay. And then next aqueous NaOH. See, at anode we have OH minus, both cases OH from water, OH from NaOH, so O2 gas will be released, no confusion there. So at cathode reduction, definitely hydrogen reduction only takes place, H plus converts into H2. Fused means there is no other cation other than sodium, that must deposit there. Next, what happens? O2 Cu, okay. So now I will be giving you one more question here. I have just let us bring the organic reactions here. So coal-based electrolysis method we will see. So coal-based electrolysis method means I am taking acetate, sodium acetate solution. Solution means this is aqueous solution now. So write it as seventh example. Now tell me, electrode is this one only, neutral like inert electrode only. So what is the product formed at here, at here? So what happens at anode, what happens at cathode? Oxidation takes place now. So from this, loss of electrons takes place anode. So just let me write the structure of this properly. CO, O minus, Na plus we have now. So at anode what we have? This anion part we have, and along with this we have H2. So this anion what happens means, so this will be releases electrons and forms CH3 CO O radical, it will form by losing one electron first. After this will comes this side, because radicals are highly unstable, and out of these two electrons one electron is taken towards itself and one will be stays with this methyl group. Now what is we have methyl radical, we have CO2 gas is released. At what electrode? At what electrode this story? Anion I have taken the, so story is at anode you should consider. Okay. So now this is the radical we have now. So now these radicals, like in the solution like that radicals we have n number of radicals, so they themselves combine to form a double of it, like a couple. So we'll get CH3 CH3. This radical from this carbon, another radical from another carbon will pair up and make a bond between them. They become friends now. Okay. So now what are the products formed at anode? Ethane and carbon dioxide at anode. So what about cathode?
Hydrogen.
So sodium, we know sodium won't deposit. So aqueous solution now, so H plus ions are there, so converts into H2 at cathode. That's it. Is that clear? Now let us solve this question. Now tell me fast. So when dilute HNO3 is electrolyzed, H2 is formed at anode. Read. O2 formed, gas is formed at anode. So tell me which is correct. They are saying more options about anode now. Let us look at the anode first. What are the anions we have?
NO3 minus
Nitrate ion,
H2O or
dilute now. Next OH minus. OH minus ion from water. So out of this, you know, we have seen sulfate now. So before sulfate you have nitrate. So they won't get deposit first. So water, OH minus ion from water only get deposits. So we'll get 4H plus O2 gas at anode. Okay. So O2 gas is released at anode. So this is correct. Okay. So remaining, see, nitrate ion is at anode. Then how can we expect NO2 gas or N2 gas at cathode? We can't expect now. So because nitrogen whatever present, that is at anode only. At cathode we have only H plus ion. So there is nothing to discuss about this thing. Okay, I explained this won't form here because H2 only getting deposited. Next, this one. In electrolytic purification, which of the following is made impure metal? Anode. Clear now that concept? This one. Next. During electrolysis of aqueous solution of salt, pH in the space near one of the electrodes is increased. So tell me. Aqueous case, what I told you? So look, out of these ions, so tell me, so at anode, so you are saying CuSO4, no, let us understand that. Anode, what are the anions we have in this? Minus, then?
OH minus.
So H2. Out of this will only deposit now, I mean oxygen from OH minus. So here we'll get 4H plus O2 plus 4 electrons. So they are saying electrolysis of aqueous solution, pH in the space near one of the electrode is increased. Which of the following solution was electrolyzed? Okay, this is at anode. So at cathode, so Cu plus 2 converts into Cu. Okay, so here concentration of H plus ion is increased. They are saying pH is increased. So pH should, this is decreasing, this is not increasing. So might not be the option, this one. So let us verify other options also. So here nitrate ion is there. We know nitrate won't go, only OH minus. So there is nothing to discuss about 3 and 4. Now look into 1 and 2. So let us look into these two. So anode, What is the anode case? Cl minus electrodes. Okay, so here we have anode Cl minus and H2O. Then next cathode Cu plus 2. Okay, for this one Cl minus and H, this is common, but
H plus.
what is the other ion we have? So H plus will deposit, converts into,
H2
so what I should write? H2O gives rise to,
H2 plus
at anode na, so what I should write? H2 plus 2 OH minus. So base is forming in which case?
KCl.
KCl. So what is the correct answer? So here it will convert into copper metal na. So OH minus is forming in which case? See, potassium we have, this won't undergo reduction, K plus won't undergo reduction when we have H plus. H plus preferentially undergoes reduction na, so forming OH minus. So which is resulting to form a basic solution? K, like this solution. So what is our option? 1. First option is correct. And one last question, tell me. On electrolysis of dilute sulfuric acid using platinum electrode, the product formed at anode. Easy.
Oxygen.
Nothing to discuss. Sulfuric acid, sulfate ion at anode, along with the dilute means water. So sulfate ion will the deposit? No. So which should deposit first? Oxygen will be formed. So O2 is released. So first option is perfect one for this. Hope this is clear. Now remaining things we will discuss in the next class. Okay. So those who are in online, so thank you for watching. If you have any queries, feel free to write in the comment box. Thank you.